So what values of x makes x squared equal 16 true? 4, right? However, is there anything else that would make this equation true? -4. So when we are taking the square root of a positive number, in order to solve if x squared equals 16, you can think of it as taking the square root of both sides. The square root of something squared, the square root and the square undo each other, and you're just left with what's on the inside. So the square root of x squared is just x. And the square root of 16, we just said, could be 4 or -4. It could be a positive or negative number. So you write your solutions, x equals, and then 4 and -4. For part 2, x squared equals 0. What can I plug in for x there? 0. Can I plug in anything else? Okay, so if x squared equals 0, the only solution is x equals 0. What about if x squared equals -16? What can I plug in for x there to make that true? Nothing. Is there anything times itself that will give you a negative number? Well, if you take a positive number, positive times positive, that's going to be positive. And if you take a negative number, multiply by itself, another negative number, negative, negative gives you positive. So nothing will give you a negative number. So you cannot take the square root of a negative number. Therefore, in this example, we just write no solutions. There is nothing that we could put in for x there that would make that true. You cannot take the square root of a negative number. Right? So, there are times when solving equations or inequalities where we will have to use square rooting to solve. What we want to do in those cases, so for example, if in part A we have z squared minus 5 equals 4, we want to get the part that's squared by itself first, and then we'll square root at the end to find our answer. So I like to say we isolate the part that is squared. We get it by itself. We want z squared equals something. Okay? So to get z squared by itself, we need to do the opposite of -5, so we add 5 to both sides. So we are left with z squared equals 4 plus 5 is 9. Go ahead. Think about what is the square root of 9? What solutions can I have for z here? I could have 3. Think about square rooting both sides. Z could equal 3. Could z equal anything else? -3. So here I have two solutions. Z equals 3 or z equals -3. Both of those values, if I plug them into my original equation, will make that equation true. So you do have to have both of those solutions. You can't have just one. Alright, looking at B, it is similar. R squared plus 7 equals 4. I want to get R squared by itself first, and then I'll square root. So, to get it by itself, I need to subtract 7 from both sides. I get R squared equals 4 minus 7 is -3. What are my solutions going to be for R here? No solutions. We can't square root a negative number. So here, I can just write no solutions. Last one. 25 times k squared equals 9. What am I trying to get by itself here? What am I trying to isolate? The k squared first, and then I'll square root to solve for k. So if I have 25 times k squared, how do I get k squared by itself? Divide both sides by 25. So I will have k squared equals 9 divided by 25. Now, again, I wanted to get just k, so I have to take the square root of both sides. When I take the square root of a fraction, I can rewrite that as the square root of the top of the fraction, which in this case is 9, over the square root of the bottom. So again, if I'm taking the square root of a fraction, I can rewrite it as the square root of the top over the square root of the bottom. Here the top is 9. What's the square root of 9? 3. Square root of 25? 5. Okay? So I solved that k could be equal to 3 over 5. However, is there anything else that I could have as a solution here? Negative 3 over 5. I have my positive and my negative solution. Questions on example 1, the first 3 problems. Example 2, we're solving for x. 4x squared plus 3 equals 20. What am I trying to isolate or get by itself first, Alyssa? The 4x squared. I want to get rid of that 3 first. So I'm going to subtract 3 from both sides. Get 4x squared equals 20 minus 3 is 17. Alright, what do I need to do next? Do I? Have I isolated the part that's being squared? No. What I want to get by itself is just the x squared. So what do I need to get rid of? I need to divide by 4 on both sides. So that will give me x squared equals 17 over 4. How do I solve for x now? Square root. I square root both sides on the left. A square root of x squared is just x. And on the right, what did we say about square rooting a fraction? We can do the top and bottom separately. So on the top, square root of 17. On the bottom, square root of 4. On the top, can I simplify the square root of 17? Is that a perfect square? No. For this purpose, if it doesn't tell you to round or plug it into your calculator, just leave it as a square root. So on the top, just leave it as the square root of 17. Since we can't simplify that. Can we simplify the bottom? What's the square root of 4? 2. If you can simplify it, do it. If not, you can just leave it as a square root. So my solution now is x equals the square root of 17 over 2. Do I have any other solutions? Negative. Okay, when I write the negative, I put the negative outside of the square root. So the negative square root of 17 over 2. Yep.
Why can't you go away divide by 4 first?
Oh, because if we divided by 4, we'd have to divide that whole side of the equation by 4. So that means we'd be dividing 4x squared plus 3 all divided by 4. So we'd get the 4's would cancel out, but we'd also have then 3 over 4. Do you see what I'm saying? And we don't want to do that. So you always want to add or subtract first and then divide or multiply. Okay? Other questions on examples 1 and 2? Alright. So number 4. I want to get g squared by itself. So first, I want to subtract the 1 from both sides. So I get g squared equals 18. Divide both sides by 6, and I get g squared equals, what is 18 over 6? 3. 18 divided by 6 is 3. If you can simplify that fraction, simplify it. Make it easier on yourself, okay? So, most of you were great up until this point. Now, what do I need to do to get just g and not g squared? Square root, because the opposite of squaring is square rooting. They undo each other. They're opposites. So I have to take the square root of both sides. So the square root of g squared gives me just g. But then I have the square root of 3. Is that a perfect square? No, I could plug it into my calculator and get a decimal, but here it doesn't ask for a decimal. So I'm just going to leave it as the square root of 3 since I can't simplify that. However, is that my only solution? No, what would my other solution be? Negative square root of 3. So again, if it doesn't tell you for a decimal, it doesn't ask you to round to the nearest whatever, just leave the root in there. Okay? Questions over any of the checkpoints? Alright, flip to the next page. On the class notes, numbers 1 and 2 are similar to what we have been doing so far. Okay? So for the sake of time, we are going to skip 1 and 2. However, if you would like to go through them after we are finished, I would be happy to do that with you. Or if you'd like to check your answers, that'd be great. But we're going to skip to 3 and 4. 3 and 4 are a little bit different. What do you guys notice is different about number 3 that we haven't seen so far? We have parentheses squared. Okay? So again, we want to isolate whatever is being squared first to get that by itself so that we can square root it and undo that square. So what we will be isolating or getting by itself here is this whole thing, x minus 3 in parentheses squared. That's what I want to get by itself. Then I can use my square rooting. So to get that by itself, what do I need to get rid of? The 2. Since it's being multiplied, I divide both sides of the equation by 2. On the left, then I will just have x minus 3 squared. And on the right, what's 18 over 2? 9. If you can simplify the fraction, simplify it. Okay? So, have I isolated the part that's being squared?
No.
Yes. In this case, we're taking the parentheses squared, right? We're taking everything that's in the parentheses squared. So, we could distribute that square, right? If we multiply this out, you don't have to write this down, but we'd get something like x squared minus 6 squared plus 9. Do we want to solve that? No, we don't want to solve that. So what we're going to do instead is we're going to square root it, and let's see what happens. If we square root both sides, remember I said the square root of something squared, the square and the square root undo each other. So the square root of the parentheses squared just leaves me with what's in the parentheses. So on the left, I'm just left with x minus 3. That square root and the square canceled each other out, and I'm just left with what's in parentheses. Put your devices away, guys. We don't need them. On the right, I have the square root of 9. What's the square root of 9? What's the square root of 9? 3. However, what do we know about taking the square root of 9? What do you guys know? 3 is the only thing that when you square it, you get 9? You also get negative 3. So now we have an equation that has 2 answers. It could be equal to 3 or negative 3. So how do we continue on and solve for x when there's 2 different things it could be equal to?
You just leave it.
We don't just leave it. We need to get x equals. We're solving for x. Okay? We're not going to plug them in because it's x minus 3 equals 3 or equals negative 3. But what we're going to do, since we have 2 different things here, we have to set up 2 different equations. Okay? So our first equation would be x minus 3 equals positive 3. And our second equation, x minus 3 equals negative 3. So now just solve both of those equations for x and see what you get. Alright? So if you solve both these equations, you still get x equals 6 and x equals 0. Notice, are these just the positive and negative of one answer?
No.
No. But I still had 2 answers earlier in my equation, which led me to get 2 different solutions for x. Okay? So I still have 2 different solutions here. Right? Questions on number 3? Okay, number 4. Again, I want to isolate just the part that we're squaring first. So here we have b plus 1 in parentheses squared. I'm going to circle that so I know, or I'm going to box it, so I know that's what I need to get by itself, and then once I have that by itself, I can square root. So, to get that by itself, first I want to subtract the 1 from both sides. On the left, I'll have 2 over 3 times b plus 1 squared equals, on the right, 11 minus 1 is 10. What do I need to get rid of next?
The 2/3.
The 2/3. If I'm taking 2/3 times all that stuff in parentheses, how do I get rid of the 2/3? Divide. What's the same thing as dividing by 2 over 3?